Hey, I assume you have been following the GutWell series so far. Today, I would like to introduce you to the concept of quorum sensing. I am Professor Vijay here, and I am back with another episode of GutWell. We have seen that bacteria can release chemical signaling molecules called autoinducers. In fact, we call them chemical communication molecules. Bacteria release them into the environment. When the level of these chemicals build up, that is, when the noise level of their chat reaches a critical level, the bacterial cells receive a signal which tells them that they have reached the quorum, that is, adequate population to enter into a coordinated action successfully. That is why we call these autoinducers as quorum sensing agents. Each bacterium has specific receptors that can detect the intensity of that chemical chatter. When this noise level reaches a certain threshold, it triggers a change in the gene expression within the bacteria. This leads to a coordinated response among the entire population, enabling them to act in unison and express their united strength. What do these bacteria talk about? By the way, through this chemical communication, let me explain this to you. Bacteria have a wish list, a list of things they have to do in order for them to survive and flourish. They use the information exchanged through quorum sensing to arrive at an action plan that will have a positive influence on the various aspects of their life. Predominantly, they would like to form a biofilm and live inside it, inaccessible to antibiotics and even to your immune system. Secondly, they would like to become more virulent, produce toxins, making them more aggressive and harmful. Realizing that it is important for us to understand the implication of bacterial communication through quorum sensing, our scientists today have started to interpret these data, this language, this noise, and understand this bacterial communication. And this has opened up exciting avenues in medicine and biotechnology. Let us take a recap. Quorum sensing is a fascinating system used by bacteria to communicate and coordinate their behaviors based on their population density. This allows them to collectively exhibit behaviors they wouldn't be able to do individually, often related to virulence and survival. Quorum sensing is a remarkable example of how even a simple organism like a bacteria can exhibit complex communication and cooperation. It is an intriguing area of research with profound implications for our understanding of both bacteria and ourselves. Now comes the very important question. Is there a way for us to overcome the challenge of quorum sensing by these pathogens and the implication of this to our health? Yes. The answer is in the name of anti-quorum sensing agents. Anti-quorum sensing agents is an upcoming action to combat this challenge by pathogens by disrupting their communication through autoinducers and thus hindering their ability to gang up on the host. Anti-quorum sensing agents are chemicals, structurally though related to autoinducers, so that they can mimic them and block the autoinducers from reaching out to the bacteria and communicate with them. The bacteria mistakes the anti-quorum sensing agent as the autoinducer and accepts it. Thus, for the real autoinducer, there is no place on the wall of the bacteria. It is like muting a TV set with a remote. Of course, these are early days of this research, and the research has to go a long way though. Once anti-quorum sensing agents come into the market, once they are in place, we can potentially disrupt quorum sensing and thus block pathogens from causing a disease and get rid of them, believe me, even without the use of antibiotics. Very fascinating, isn't it? We will talk about it later.
Professor, you talked to us about something called an anti-quorum sensing agent. So, how does that exactly work and how is it different from an antibiotic? And to hear with all the antibiotic resistance that's going on, it's good to know that there's a solution for this problem. So, could you please elaborate on that?
Anti-quorum sensing agents act by disrupting the bacterial communication, as simple as that. Anti-quorum sensing agents disrupt the bacterial communication basically throwing a wrench into their plans. As I said, research on anti-quorum sensing agents is still in early stages, but the potential is huge. You know what they can offer? They can offer new antibacterial strategies. A novel way to fight bacteria without relying on traditional antibiotics, potentially reducing the resistance, as you were asking. Enhance the effectiveness. They can enhance the effectiveness of existing antibiotics. Combining anti-quorum sensing agents with antibiotics could make them more effective because the bacteria becomes weak with anti-quorum sensing agents. In fact, it helps to break the biofilm, which protects the bacteria against antibiotics, so your product will work, your antibiotic will work. And more importantly, biofilms cause problems in various industries, from medical implants to oil pipelines. Anti-quorum sensing agents could be incorporated into materials to prevent biofilm formation. Take, for example, dental implants. You can incorporate anti-quorum sensing agents in that to prevent biofilms forming on the implants.